Einstein won his Nobel Prize for predicting, based on his photon model of light, that data from experiments on the photoelectric effect should have a slope equal to Planck's constant. Now, this class isn't really about the details of everything I just said. The main thing to understand here is that Einstein, hopefully we all recognize that name, is a really famous physicist. This is what he won his Nobel Prize for. It's actually maybe not the thing he's the most famous for, because he's maybe most famous for like E equals mc squared and the theory of relativity and all that kind of stuff. But this is one of the important foundational building blocks, you could say, of quantum theory that Einstein also had a really prominent role in developing. But the question here is, how could Einstein's photon model have been falsified? And that's something, even without necessarily knowing the details of what a photon is, probably most of you heard of it, or especially if you don't know the details of the photoelectric effect. If you want, you can Google that, have fun, but don't feel like you have to. But it says here that his prediction essentially was that it should have a slope equal to Planck's constant. And what this graph here shows, these circles actually represent data from an experiment done by Millikan from 1916. Millikan is actually also kind of famous for being the first person to determine experimentally the value of the charge of an electron. Anyway, this, like, the question really is, though, like, what could have happened with this experiment that would have clearly shown Einstein's whole model, his whole idea, to be false? And the simple answer is, since it says the slope needs to be equal to Planck's constant, a simple way to answer this is to say, well, what if the slope were not equal to Planck's constant? That would be one way. It could get even worse, though. What if these data points that come from measurements, right? This is a really intricate experiment involving electrical equipment, like a vacuum tube, stuff in it, light being of different frequencies, hitting pieces of metal in there and stuff like that. Very complicated. The data could have been graphed afterwards and like been all over the place, or been in a curve or something like that. And then to say that the prediction is it should have a slope equal to Planck's constant, there would be no way for that to really work. So that's another way that maybe it could be falsified. So let's go ahead and check out the answer here on this slide. It says the slope of the line the data falls on could have been different from, oops, I think I meant to say Planck's constant there instead of Planck's constant. Or even worse, the data could have significantly deviated from a straight line. Since instead the data did exactly what Einstein predicted, the photon model became widely accepted and remains so to this day. So if you've heard of it, that's why, because it hasn't been falsified yet since then by anything else. And there's been plenty of other tests where it could have been. So in other words, other experiments have continued to show good agreement with the photon model without any falsification having happened. I put a little interesting little maybe jab at something here about pseudoscience here, because it's interesting that arguments made by pseudoscientists to support the existence of cold fusion require that the very model that I'm talking about here, this really famous model that's been rigorously tested in tons of other experiments, it requires it to be false on this hope that cold fusion might solve all our energy woes and so on. So, if you've heard of that, I mean, I don't want to malign anyone who maybe believes in cold fusion, but just recognize it's really kind of going against a lot of science. It really is in the realm of pseudoscience.